guys, here is 2.5 Day 2 Notes video number 3. We're going to talk about holes in this video. Holes occur when you have a factor in the numerator and the denominator that are the same. So if the numerator and the denominator have common factors, you can cancel it out, which means you lose an asymptote, but you gain a hole. So let's look at example number 2. So here, the top factor says x minus 2, x plus 2. On the bottom, my factors are x minus 4, x plus 2. So if you notice for this one, I could cancel out my x plus 2's, and I get x minus 2 on the top, x minus 4 on the bottom. All right, so then for my vertical asymptote, I have x equals 4. That's what's going to make this a 0 here. Notice because I got to cancel this one out, this is no longer an asymptote. That's actually going to be a hole. For my horizontal asymptote, the degree of my numerator is the same as the degree of my denominator. So it's going to be leading coefficient divided by leading coefficient, or y equals 1. For my oblique asymptote, since I have a horizontal asymptote, I'm not going to have an oblique asymptote. I know this because this is not 1 degree over this one. And then for my hole, I do have a hole for this one. My hole occurred wherever I have this guy that canceled out. So this guy canceled out was positive 2. What would make that a hole is that negative 2. If I wanted to figure out roughly where the value of this point would be, so notice if I plug in negative 2 into my original equation here, if I plugged in negative 2, I would get undefined because the bottom would be 0. But if I plug it into the reduced version, this would be minus 2 over minus 2 minus 4. So this is going to be negative 4 over negative 2 minus 4 would be negative 6. So that's at positive 2/3. That's where the hole is going to exist, is at negative 2/3. All right, and then for my x-intercept, that's where my numerator is equal to 0. You have to be careful though, we don't want to use this numerator here, because if I looked at this numerator, I'd say, well, it's 0 when this is 2 and when it's negative 2. But we just said at negative 2, I've got a hole there. So this would be a hole. Sorry, this piece here would be a hole. So my only x-intercept is when x minus 2 is equal to 0 or x is equal to 2. So 2, 0 is my only x-intercept. For my y-intercept, we're plugging in 0. So I got 0 minus 2 over 0 minus 4. I plugged it into the shortened version over here. Negative 2 divided by negative 4 would be 1/2. So I've got a y-intercept at 0, 1/2. And let's go ahead and graph this. See if I can. I'm probably not going to get it to pop up here. All right, so when I graph this, I've got a vertical asymptote at x equals 4. I've got a horizontal asymptote at y equals 1. I do not have an oblique asymptote. I know I have a hole at negative 2/3. So that's going to be in here. It's really hard to get right on 2/3, but you get the idea. I have got an x-intercept at 2, 0. I've got a y-intercept at 0, 1/2. So here's my graph. It's getting close to this hole, but not touching. I think the other half is probably up here, but how can I confirm that? I'm going to choose a number bigger than 4 and test it. So finding h of 4, f of 4, h of 4. If I plug that into its condensed version, sorry, it's got to be bigger than 4, Miss Harris, so it needs to be h of 5. When I plug 5 into my condensed version here, I get 5 minus 2 over 5 minus 4. This would be 3 over 1. So I have a point at 5, positive 3. So it's going to be above the asymptote. All right, that's example number 2. Let's look at these U-tries. For number 1, let's go ahead and factor out our numerator. That'll be x plus 4, x plus 6. For my denominator, my two values would be x plus 4, x minus 3. Which of these can you cancel out? That would be these two. Be careful on your quiz. Don't second guess your factoring. Make sure your factoring works. You may not always have something that can cancel out there. All right, so then our our vertical asymptote would be x equals 3. My horizontal asymptote, my degrees are even, so it's going to be coefficient divided by coefficient, or 1 divided by 1, which is 1. I do not have an oblique asymptote because my degree of my numerator is not bigger than the degree of my denominator. But I do have a hole right here with the one that I canceled out. So that would be x equals negative 4. If you want to find out where that other piece is of it, I'm going to plug in negative 4 into my reduced version, which is this guy here. If I plug in negative 4, then I get negative 4 plus 6, negative 4 minus 3. This would be 2 over negative 7, so negative 2/7. That's where the hole is. Today in class I just said x equals negative 4. If you put x equals negative 4, you're going to be fine there. But if you wanted to get a better idea of where it's going to be on your graph to make sure your graphing is right, feel free to do that. All right, for our x-intercept, that is where this guy is equal to 0. So that would be at negative 6, 0. For my y-intercept, that's when I plug in 0 for x here and here. I get 6 divided by negative 3 would be negative 2. So let's use all of that information and see what we can get for our graph. We have a vertical asymptote at x equals 3. We have a horizontal asymptote, if I remember correctly, at y equals 1. We do not have an oblique asymptote. We've got a hole. We said at negative 4, negative 2/7. So that would be 1, 2, 3, 4, somewhere in here. It's really hard to nail down negative 2/7 on the graph. 1, 2, 3, 4. I know I've got an x-intercept at negative 6 and a y-intercept at negative 2. So we've got this piece of our graph mapped out pretty well. Again, it's probably going to be up here, but let's test a point just in case. For the simpler ones, it's pretty obvious, but for the bigger ones, when you start adding different degrees in there, it's not as obvious what it's going to look like. So some number bigger than 3 would be 4. So let's try g of 4. I'm going to plug it into this version here. That'd be 4 plus 6 over 4 minus 3. That'd be 10 over 1. So g of 4 is a positive 10. So we are up here. Oops. And so my graph would look something like that. Again, it doesn't have to be precise as long as you can show me where your hole. I'm going to be looking for your hole. I'm going to be looking for your asymptotes and making sure your graphs are in the right pieces. The other thing that it asks you for is to find your domain, and you'll see this on your quiz tomorrow. So my domain for this guy would be from negative infinity to my hole, which is at negative 4. It's my first break of my x's. And then from negative 4 all the way to my asymptote, which is negative 4 to 3. And then again from 3 to infinity. All right, and for our b, again, let's start by factoring this guy. This would be x minus 3, x plus 1. The denominator factors as x minus 5, x plus 1, which means the x plus 1's cancel. My vertical asymptote would be at x equals 5. My horizontal asymptote, the degrees are the same, so it's coefficient over coefficient, or y equals 1. Since I have a horizontal asymptote, I know I don't have an oblique asymptote. For my hole, that's for the factor that I canceled out. So X plus 1 canceled out, so I now have a hole at -1. If I wanted to figure out the y value for that, I could plug it into my reduced version, which is x minus 3 over x minus 5. So figuring out that hole, that would be -1 minus 3, -1 minus 5, it's -4 over -6, which would be positive 2/3. X-intercept is when my reduced version, where the numerator is equal to 0, and that would be at positive 3. Y-intercept, again, we're looking at that reduced version, putting in 0 for x, and I'd have -3 over -5, which would be positive 3/5. All right, let's graph this guy. We got x equals 5 for our vertical asymptote, 1, 2, 3, 4, 5. We've got y equals 1 for our horizontal asymptote. We have a hole at -1, positive 2/3. I've got a y-intercept at 0, 3/5. I've got an x-intercept at 3, 0. You guys see how this guy gets really stretched out and gets close to that asymptote? Again, I think the other piece lies up here, but we can check that. This is 5, one bigger would be 6. So 6 minus 3, 6 minus 5, that's going to be 3 over 1. So again, 3 is up here. So we do have this piece of our graph, like so. And there you go, that's your notes for day 2. You have a quiz tomorrow. Good luck studying. Send me an email if you have any questions about your homework.